The Tacoma Narrows Bridge. At 11 a.m. on November 7, 1940, the center span of the Tacoma Narrows Bridge tore itself apart. Steel cables snapped like guitar strings. The roadway twisted 28 feet in opposite directions, then broke free and fell into the Puget Sound below. Newspaper editor Leonard Coatsworth crawled to safety on his hands and knees. His dog, trapped in the car, fell with the wreckage. The bridge had been open for just 4 months. From opening day, drivers reported something wrong. The roadway would rise and fall in gentle waves. Cars ahead would disappear, then reappear as the road undulated. Local residents called it Galloping Gertie. Engineers noticed but believed it would stabilize. It didn't. The bridge had been designed thin and elegant. The roadway was unusually narrow, the support structure lighter than previous suspension bridges. No one had tested how wind would interact with the shape. On that November morning, 42-mile-per-hour winds hit at the wrong angle. The oscillations amplified. Within minutes, the feedback loop became unstoppable. The disaster led to mandatory aerodynamic testing for all suspension bridges. The replacement bridge, completed in 1950, has stood for over 70 years. Bridges should not dance. The Hyatt Regency walkway collapse. At 7:05 p.m. on July 17, 1981, the fourth-floor walkway at the Hyatt Regency Hotel in Kansas City dropped. It fell onto the second-floor walkway below. Both structures crashed to the lobby floor in seconds. 114 people died. 216 were injured. The lobby had been packed with 1,600 people attending a tea dance. The suspended walkways allowed guests to watch the atrium below. At the moment of collapse, dozens stood on the walkways. Others were directly beneath them. Engineers studied the wreckage. Within weeks, they identified the cause. A single bolt connection had failed. But the failure wasn't random. It was inevitable. The original design called for continuous steel rods to hang both walkways independently from the ceiling. During construction, the contractor requested a change. Instead of one long rod through both walkways, they wanted 2 shorter rods, one for each level. The change seemed minor. It made installation easier, but it doubled the load on the fourth-floor connection point. In the original design, each walkway held its own weight. In the revised design, the fourth-floor walkway supported itself and the entire second-floor walkway hanging below it. The box beam connections were not designed for this. The welds held for a year. Then, under the weight of the crowd, they gave out. The structural engineers who approved the change were found guilty of gross negligence. They lost their professional licenses. Today, it's taught in every engineering ethics class. 1 bolt, 114 lives. Deepwater Horizon. At 9:45 p.m. on April 20, 2010, methane gas shot up through the Macondo well, 18,360 feet below the Gulf of Mexico. It reached the Deepwater Horizon drilling platform in seconds. The gas ignited. The explosion killed 11 workers instantly. Survivors jumped into the ocean. The platform burned for 36 hours before it sank. But the explosion was just the beginning. The well was still open. Oil gushed from the broken pipe on the seafloor. Earlier that day, pressure tests had shown something was wrong. The cement seal at the bottom of the well was not holding. Halliburton had recommended using 21 centralizers to ensure even distribution. BP decided to use only 6. The reason? Cost and time. The inadequate cement job failed under pressure. When the methane broke through, automated safety systems should have stopped the blowout, but some had been overridden. Others were not functioning. After the explosion, BP attempted to cap the well. A containment dome failed. A top kill procedure failed. A junk shot failed. For 87 days, oil poured into the Gulf of Mexico. On July 15th, a capping stack finally stopped it. By then, 210 million gallons of crude oil had spilled, the largest marine oil spill in history. Thousands of miles of coastline were contaminated. Entire ecosystems collapsed. BP paid $20.8 billion in fines. Internal emails revealed that engineers had raised concerns about the cement job. The warnings were ignored. 11 men died because someone decided 6 centralizers were good enough. The Banqiao Dam failure. At 1 a.m. on August 8, 1975, the Banqiao Dam collapsed. A wall of water 10 meters high and 15 kilometers wide exploded through the valley below. Entire villages were erased in minutes. People sleeping in their homes were swept away before they could react. But the nightmare didn't stop there. The flood reached the Shimantan Dam downstream within hours. That dam failed. Then another. And another. The cascading water triggered the collapse of 60 additional dams across Henan province. A domino effect that turned rivers into tsunamis. 3 days earlier, Typhoon Nina had stalled over central China. In 24 hours, the storm dumped more than 1,000 millimeters of rain, an entire year's worth of precipitation in a single day. The Banqiao Dam had been built in 1952 with Soviet assistance. It was designed to withstand a once-in-1,000-year flood. The typhoon exceeded every projection. Water poured into the reservoir faster than the gates could drain it. Engineers tried to open all the gates, but silt and debris had jammed several. Communication lines were down. They couldn't warn the towns downstream. When the structure failed, the destruction was biblical. Official counts listed 26,000 deaths from drowning, but famine and disease followed. Crops were destroyed. Infrastructure was gone. Medical care collapsed. Estimates of total deaths range from 85,000 to 230,000. The Chinese government suppressed information for years. When details emerged, Banqiao became a case study in cascading failure, proof that single points of failure in connected systems can trigger catastrophes beyond imagination. Chernobyl. At 1:23 a.m. on April 26, 1986, a shift supervisor inside reactor number 4 at the Chernobyl nuclear power plant pressed the emergency shutdown button. The control rods began to descend into the reactor core. They were supposed to stop the nuclear reaction. Instead, the reactor exploded. Power surged to more than 100 times normal output in under 3 seconds. Fuel rods shattered. Steam pressure blew the 1,000-ton steel and concrete lid off the reactor. A second explosion followed. Burning graphite and radioactive debris shot hundreds of feet into the air. 2 workers, Valery Kodymchuk and Vladimir Shashanok, were killed instantly. But the explosion had been set in motion 12 hours earlier. On the night of April 25th, operators had begun preparations for a safety test. The test was designed to see if the reactor's turbines could generate enough electricity to power emergency systems during a brief gap before backup generators activated. To conduct the test, multiple safety systems were deliberately disabled. The reactor being tested had a fatal design flaw. Under low power conditions, the RBMK-1000 reactor could become unstable. Its positive void coefficient meant that as steam formed in the cooling water, the nuclear reaction would accelerate instead of slow down. Soviet engineers knew about this. The reactor operators did not. As the test began, power dropped too low, to just 30 megawatts instead of the planned 700. In attempting to raise it back up, operators violated protocol after protocol. They withdrew control rods far beyond safe limits. When they finally pressed the emergency button, the design flaw activated. The graphite tips of the control rods briefly increased reactivity as they entered the core. The reaction spiraled out of control in seconds. Radiation spread across Ukraine, Belarus, Russia, and into Europe. Firefighters who responded received lethal doses of radiation. 28 died within weeks from acute radiation poisoning. Over 350,000 people were evacuated. The entire city of Pripyat, population 49,000, was abandoned and remains a ghost town today. Long-term cancer deaths from radiation exposure are estimated between 4,000 and 90,000. The economic cost exceeded $235 billion. The test was supposed to prove the reactor was safe. Instead, it proved that overconfidence kills. 5 disasters, 4 continents, 7 decades. Every single one started the same way. Someone ignored a warning, someone cut a cost, someone said, "It's probably fine." The math didn't care, the physics didn't negotiate, and when the system broke, it broke all at once.